Everyone. This lesson today is section 5.1 from your textbook, and the topic is something called compound sentences and inequalities. To be honest, I don't know that you'll ever refer to these as compound sentences again, but your textbook uses that phrasing. Really, it's a matter of sentences involving inequalities, and then compound sentences would be when we're working with more than one of them at the same time and how they interact with each other. But before we can move in that direction, we kind of have to make sure that we remember how inequalities work. And I believe that most of this stuff is covered back in junior high, but just in case you need a refresher, first off, we've got the greater than symbol and the less than symbol. You do want to make sure you know the difference between those two. If you can't look at this visually and know that it's a greater than, you want to put a little bit of work into memorizing those two things, okay? That this is the greater than symbol, this down here is the less than symbol. So this statement says x is greater than 4. That means I want to show on this number line everything that is greater than 4. The thing is, when I have it written this way, I want to show everything that's greater than 4, but not including the 4. So in order to show that, and we kind of talked about this a little bit when we did step functions, I'm going to put an open circle right there on top of the 4, and then greater than would be everything to the right. So I'm going to shade my number line in everywhere to the right of that x equals 4. Now, this one here, this is a less than, so I want to show everything less than -2. But this little guy right here, that's an equal bar. And that means that it's okay for x to actually equal -2 as well. So that's a less than or equal to symbol. That means I want to include the -2, and I'm going to show that by using a filled in circle. And then less than would be everywhere to the left. So I'm going to shade it everywhere this way. And what I'm representing when I do that shading is all of the possible values of x, because x can be anything less than -2. My shading's not very pretty there. Okay, so starting down here, we've got some that we have to do a little bit of solving for. And you can solve inequalities just like you would solve equations. So like for this one, I would probably start by adding 1 to each side. There is going to be one minor difference, and I think we'll hit that down here. So we have 2x is less than 6, and then I'm dividing by 2 and dividing by 2, and I end up with x is less than 3. So I just treated that less than sign almost like an equal sign all the way through. I solved it like an equation. I ended up with x is less than 3. Just like up here, if it doesn't have the equal bar with it, I'm going to represent that with an open circle, okay, to show that I'm not including 3 itself as a possibility. And then I want to show everywhere that's less than that. So I'm going to have to shade in this direction, though. Okay. So everywhere to the left of that -3. And what I'm really showing, of that +3. What I'm really showing there is what are the possible values of x that I could plug in here and make it a true sentence, okay? So if I picked, let's say, I don't know, from over here, if I picked this -4 right here and plugged it into my inequality, picked up a old calculator here, but this will work. So if I go 2 times -4 minus 1, okay, so I plug that -4 in for x in my inequality, I should get something less than 5. And I would agree, -9 is less than 5, okay? Okay, so now let's look at this next one. 1 minus 3x is less than or equal to 7, so I would probably start by subtracting the 1 on each side. That part's going to be normal, okay? So -3x less than or equal to 6. My next step here would be to divide by the -3, and this is where things get weird. So the real issue here is, and I could talk forever about why this works the way that it does. I'm going to try not to bore you here. But numbers run in opposite directions, right? The positive numbers get bigger going this way. The negative numbers get, quote unquote, bigger. The absolute value gets bigger going this way, okay? When you divide by a negative number, you're switching your value from somewhere on the positive side to somewhere over on the negative side where things run in reverse, okay? Or vice versa. If it was already negative, dividing by a negative swings it back over here. To compensate for that, whenever you divide by a negative number, okay, your inequality sign has to flip. Okay, so when this number here that you're dividing by is negative, what's going to happen is your inequality is going to change directions, and this will now become a greater than or equal to negative 2. Okay? I'm going to go ahead and draw that on the number line, and then I will verify for you that what I'm saying is true. So greater than or equal to negative 2, because it's got an equal to, I'm putting a closed circle on negative 2. Greater than would be everywhere to the right. Okay? So again, just to verify here, if I pick a number greater than negative 2 and plug it in here, I should get something less than or equal to 7. So let's just pick 0, for example. So if I put a 0 into this function, 1 minus 3 times 0. Oh, you can't see that, sorry. 1 minus 3 times 0. I'm hoping to get something less than or equal to 7. And I do, I get a 1, okay? So that justifies for me that this is the correct way to shade this thing, even though that inequality was originally a less than. If I hadn't flipped it here, okay, if I had left it as a greater than or equal to, I would have ended up shading, I'm sorry, if I had left it as a less than or equal to, I would have ended up shading this way to the left. But watch what happens if I plug in a negative 5. 1 minus 3 times negative 5 becomes 16. That's not less than 7. So this half of the number line would not make my inequality true, okay? That's why this flip thing is so important. Anytime you divide by a negative number, you have to flip your inequality. And you may want to pause the video right now and make a quick note of that, okay? Anytime this happens, you have to flip your inequality around. Okay, so let's get into the real fun for today. We're going to start talking about unions and intersections, okay? And you talked about these in geometry, I believe, but the union is the set of all objects. And let's be real, if we're talking math, we're talking numbers, not objects, but the set of all objects in set A or set B, okay? And I guess I should throw in here, or both. If an item happens to be in both sets, then it's included in the union. The definition for intersection, and we're going to illustrate what this means in just a second, but definition for intersection is going to look almost exactly the same, except I'm going to change one key word, and that's the word that makes all the difference. So the intersection is the set of all objects, again, typically numbers, in set A and set B. Okay? Very tiny word choice here, but union uses or, intersection means and. Okay? So when I'm talking about the union, if this is group A in this circle and this is group B, I'm inviting anyone in this circle or anyone in this circle to the party. And if they happen to be in the middle here where they have both, they're all getting invited. This whole thing, all of this, is the union of these two sets. There's a symbol that we use for union, by the way. I would say A, and then I use this symbol that kind of looks like a U for union. B. This symbol right here means union, and you're going to need to know that on the next page, okay, and on your homework tonight. So union includes everything, right? If it's in this circle or if it's in this circle, and if it happens to be in both, great, but that includes everything. The intersection includes only the items that are in both. So that's only this section in the middle. This would be your intersection, okay? And so this right here is the intersection. And we, again, have a symbol for this. This looks like an upside down U. Some people call it an N. I don't think it's really supposed to be an N. But that symbol right there, that's for intersection, okay? So intersection, you only get invited to the party if you're in both groups at the same time, okay? And so again, we're going to be using this wording on the next page. But this is what I mean when I say compound sentences. Up at the top, we said this lesson is referred to as compound sentences. We're going to be taking mathematical sentences, like these inequalities up here, we're going to be working with two of them at the same time. We're going to have to decide if we're looking at a union or an intersection, and then we're going to show that on the number line. That's kind of our goal for what we're moving into next. All right, so let's take a look at some of these examples. Oops, flip too many pages. So that very first one, x is greater than or equal to 2 and x is less than 4. So what I want to do here somehow is show the numbers that fall into this group and this group at the same time. This and shows me that this is an intersection problem. When it's an intersection problem, you want to make sure that your final answer only includes numbers that are in both groups at the same time. So what I typically do with these, and you'll see me do this off to the side here, is I'm going to graph each one of these individually up above the line, and then I'm going to make a decision about what should go on the line itself as my final answer. So however you make your number lines is fine with me, as long as it's very clear to me which one is your final answer. Okay? So x is greater than or equal to -2. That would be a closed circle on -2. And greater than would be everywhere to the right. Okay. Everywhere less than +4 would be an open circle on +4, and everywhere to the left. And the intersection would be what they share in common. Okay, so the numbers that are in common are these ones that kind of got double shaded here. And so if I kind of follow this straight down, this was a closed circle, so I'm going to put a closed circle on -2. Follow this one straight down to an open circle on +4, and then I'm going to shade everything in between. And this that I'm shading here in purple, that's my intersection. Okay, so I can do this as like scratch work up above, but this is what I want to be representative of my final answer. Those are the numbers that fall into both groups at the same time. Now, look at the difference between that and this next one. This next one is an or situation, okay, which is a union. Unions are much nicer because that means everyone gets invited to the party. So I just want to shade anything that is greater than -2 or less than 4. For those ones, I can just go straight to the number line and start shading because I'm inviting everyone to the party. So x is greater than or equal to -2, just like we talked about up above. Closed circle, shade to the right. Less than +4. That would technically be an open circle, but that +4 got shaded as part of the greater than or equal to -2. So we are still including that 4, even though it's not included in this group because we're working with a union now. And we're shading everywhere to the left. And ultimately, on this one, we ended up shading in our entire number line. So if this is who I was inviting to the party, all real numbers are coming along for the ride. Okay? This includes all real numbers. Everything is included in one or the other. Okay, the notation on the next one is a very common one used in math, and the better you get at understanding what this is saying, the better off you'll be. Okay? This is really a fancy notation for intersection. Okay? Here's what it's really saying. If I read this but backwards, this is really saying x is greater than 3 and x is less than 5. Okay? But really, when you see this notation, what I want you thinking is x is everything between 3 and 5. It's kind of doing this part for you. It's kind of saying, what are your two endpoints? Shade everything in between. Okay? So I could do it like I did up here, and I could take these two and graph them separately up above. But just from the way this is written, I know that my x is everything between 3 and 5. Everything bigger than 3 and less than 5. Neither one of those has equal bars. So I'm doing an open circle on 3, open circle on 5, shade in between. Okay? All right, look at that notation on that next one. This is something called set builder notation. And I don't know that set builder notation is all that important for you to be able to do at this point, but you should be able to read it, okay? And so all this is saying is this is x such that x is greater than 2. This is the part we really need to focus on. Remember this symbol that we talked about just a minute ago? That's a union symbol, so that's an or. And then over here, the important part is that x is less than or equal to -3. The good news is the ors, kind of like we talked about up here with this one, means everyone gets invited to the party. So I can just take both of these things and throw them on the number line at the same time. If they happen to overlap, great. If not, okay, that's fine too. But we want to include all of this. So x is greater than 2, be here. X is less than or equal to -3 would be close circle and shade to the left. And that's okay that there's no overlap, right? Because we weren't looking for an intersection. So if this is who I was inviting to the party, these people and these people get to come. Sorry about these guys in the middle, okay? But just make sure your directions are going the right way. Sometimes those union ones are going to look like this, where they kind of go off to the sides. Sometimes they're going to happen to overlap, and then you get something like this up here, where it's including everything. And one more of these to get through. So this last one, this is an intersection, okay, which is an and. But there's actually an intersection inside your intersection, because see this? This is another intersection, kind of like we talked about up here. This is saying x is everything between -1 and 3, but we want to know where does that overlap with when x is greater than 1. These are the things we want to focus on, okay? So just like I did in the very first example up at the top here, I'm going to shade these separately up above and then decide what my final answer looks like. This is going to have a closed circle at -1, an open circle at +3, and I'm shading everything in between. This is going to just be a closed circle at +1, and I'm shading everything to the right because it's just greater than. And so then what I'm really looking for, what I really care about, is where do these things overlap, right? And so this overlaps from -1, the closed circle. Nope, just kidding. Sorry about that. Made it this far without making a mistake. Overlap would be this area here. So I'm not looking at this dot, I'm looking at this one. Something felt wrong about that. Closed circle at +1, open circle at +3. Okay, and so this area here is where we got double shaded. So these are the only numbers I want to represent as part of my final solution. These are problems that we really are going to have a hard time with. Well, no, I shouldn't say that. We're not going to have a hard time with them, but you won't know what you don't understand until you try some of them on your own. You can watch me do them all day long and they'll make sense. It won't be until you try some on your own that you figure out what questions you might have. So, with that being said, we are saving example 2 for Wednesday's lesson. Okay, so you are not doing example 2 today. Really, this is what you need to know for homework for tonight. Your homework is section 5.1 from the textbook. So you can go ahead and get started on that. We'll see what kind of stuff you bump into that you might need some help with, and we'll get you squared away when I see you in class again, I believe on Wednesday. So, okay, that's it for today. Have a great day.